Good morning to everyone. In the last class, we discussed about column chromatography, which is our first chromatographic technique. And the next chromatographic technique is thin layer chromatography. Simply, we call it as TLC. In thin layer chromatography, also the stationary phase is solid and mobile phase is liquid, same like as our column chromatography. Stationary phase is solid and mobile phase is liquid. And what is the principle behind this TLC is adsorption. So like column chromatography, TLC is also an example for adsorption chromatography. Now we will see what will happen in this TLC. Before entering into the main topic, what is the use of this TLC? Actually, TLC is the most popular chromatography which is highly used in the laboratories. Why? Because in the column chromatography we need so much of eluent, means we need a bulk quantity of eluent to separate A and B quantitatively. But whereas here we need very less amount of eluent, that is mobile phase. Similarly, the separation of A and B also we need only one drop. We need only one drop, so that using that single drop only we are going to tell how many compounds are present in that one. So TLC is highly useful and highly popular because the quantities of this eluent as well as the compound mixture what we are separating, we need very less quantities. Okay, and moreover in the column chromatography we need some time to do the experiment, but whereas TLC will get finished off within 5 minutes. Only very less time is enough to get the values using this TLC. So that's why TLC is the most popular chromatographic technique, so that these laboratories they are highly using this TLC in their labs. Now using this TLC, what are the applications or what are the uses about this TLC? Uh, Detect number of compounds in the sample. How many compounds are present in the sample? Detect the number of compounds present in the sample. Right. And next one is monitors the progress of organic reactions. Monitor the progress of organic reactions, means after 5 minutes of time how much is the product formed, after 1 hour how much is the product formed, or how much is the reactant left over. Okay, and the next of course identify that unknown compounds. Identify the unknown compounds. So there are so many uses are there using this TLC. Now we will enter into this TLC experiment. We have a different steps. First one is stationary phase. This we are calling it as a preparation of TLC plates. Preparation of TLC plates. Actually, this preparation of TLC plates is the main task in this thin layer chromatography, right? So, actually this TLC you have a demonstration experiment in your current lab. Okay, so here you need to take a separate TLC plate which is available in the market, or simply you can take a micro slide. To this slide we are pouring this slurry which is made up of silica gel G, where G means gypsum. That is, what is that gypsum? CaSO4 half H2O. In column chromatography we use silica gel or alumina, but here there is a special grade prepared silica gel G or alumina G, are used here in this TLC. Why? Because this slurry, what we are preparing using this silica gel G or alumina G, that slurry will gets more stick to this plate due to the presence of this G, that is gypsum. Suppose I want to prepare this slurry, this gypsum CaSO4 half H2O. How we are preparing this slurry? Actually, that part already we covered in our previous video, that is column chromatography. Take some silica gel G powder and add some water and made it in the form of a paste, semi-liquid paste. So when you are adding water to that one, this CaSO4 half H2O will become CaSO4 2H2O. So that which increases the binding capacity on this slide. So that's why we need to take this silica gel G. So this silica gel G we are preparing, and you need to pour upon this sample so that there should be no lumps. And that liquid should be poured on this slide evenly. There should be no uneven gaps, no lumps. Even to evenly we need to pour this silica gel G onto this slide. After some time you need to keep that aside for some time so that this plate will get dry up. So this is the preparation of this stationary phase in TLC. So here we are taking a micro slide and a silica gel G, the which is available in the market readily, which is in the form of powder. To that water we are adding and made it in the form of a slurry, and that slurry placing this slide in the form of inclined position. What is meant by inclined position? Like this, like a slide in the park. So putting here in the slide, and by using a special type of instruments you need to pour that, so that because slide is there, right, the liquid will slowly run down. And again by using some blade you need to just rub it so that there should be no gaps. If any lumps are there, uh, that also be removed, so that this slurry will get smooth coverage on the top of this slide. And when you dry it for 5 to 10 minutes of time, it will get dry up. And next one is, what is our next point? The next point is application of sample on this TLC plate, that we are calling it as spotting. Take a small beaker, in the take that reaction mixture A plus B, add a little amount of organic solvent, same like as our column chromatography. Take a micropipette and just place as a small drop. Take like as a small drop, just put that drop just 1 centimeter above this slide. ఈ కింద ఉన్న గీత నుంచి 1 centimeter టాప్లో we need to put like as a spot. So that is called what? Spotting. Application of sample. What reaction mixture we want to separate, that reaction mixture is added to a little bit of organic solvent, and that is placed as a spot at 1 centimeter above to the level of this micro slide. That is what? TLC plate. And next, third one is development of TLC plate. Development of TLC plate, which are available. This actually we have a TLC chamber. Generally in normal labs also we have that TLC chamber. Let us suppose I'm little bit poor in the diagrams. So let us suppose this is a TLC chamber. In the TLC chamber, take a little amount of eluent, that is what? Mobile phase. And open this lid and place this TLC plate. Just place this TLC plate here. Just place this TLC plate here. After some time, what will happen, because this is a plate which is coated with this silica gel G, while touching this mobile phase, due to this capillary action, what will happen, this mobile phase will percolates into this silica gel G and it slowly comes upward direction, slowly comes up, right? So, and here what is this spot? This spot is nothing but what? A and B. Actually, depending upon the polarity nature, this A and B will get adsorbed to this stationary phase. But when the mobile phase is coming up, this A and B, depending upon their adsorption strengths, they will also travel along with the solvent. After some time, you will observe that this solvent level is moving up, and it will reaches around 4 by 5th height of the TLC plate. Around 4 by 5 of the TLC plate. You need to note down it as solvent front. This part is called development of the TLC plate. Now, when this solvent is reaches to this place, what we need to do? We need to remove this TLC plate. So, fourth point is what? Detection of compounds. Detection of compounds. So, how we are going to detect the compounds? When this mobile phase coming up and it reaches to this level, you need to remove that TLC plate and keep it aside for 2 to 3 minutes. Actually, this is the main spot what we put here, and this is what solvent front. Already we noted down using a pencil. Take a pencil and note down here a line, and after 3 to 4 minutes of time or 5 minutes, you will observe that the spots are like this. The spots are like this, which is B, and this is what? A. B is more polar, so that's why it travels slowly, and A is less polar, that's why it travels quickly along with the mobile phase. Because B is so more polar, it is more adsorbed to this stationary phase, so it will move up slowly, whereas A is less polar, which has a less adsorption towards the stationary phase, so it will move up quickly. Okay, so finally, if anybody asks you what is the basic principle behind this, is adsorption strength. Of course, here the partition coefficient is nothing but concentration of A in stationary phase by concentration of A in mobile phase. This is the basic principle. Okay, so here the stationary phase is adsorbed by this A and B, whereas the mobile phase is causing desorbing of this A and B. So I'll show the same concept what I wrote on this paper here in this diagram. See here clearly the diagrams are you are seeing here. Step 1 is preparation of TLC plate. How we are preparing the TLC plate? Silica gel is coated on TLC plate. What is the second step? Second step is spotting. Spotting means that the sample what we want to separate, that sample using a micropipette, you are placing a drop at 1 centimeter above this line. Next, what is step 3? Development of the TLC plate. This TLC plate is placed into the TLC chamber. Okay, and the TLC chamber already contains what? Eluent, that is mobile phase. After some time, we will observe that solvent will move up and reaches to 4 by 5th level of this slide. So that you need to mark it down using a pencil, that is called solvent front, and remove the TLC plate from the chamber and put it for 5 minutes of time. You will observe that there are two spots clearly. One is B and one is A. That is nothing but B means which is more polar and A is less polar. Now how can if it is a colorless compounds, how can I guess? Suppose if there are colorless compounds, you need to place that TLC plate in the iodine chamber. If you put it them in the iodine chamber, then after few minutes of time you will observe two colored spots. Next, how can I know yes this is A and this is B? This can be known by using their RF values. RF values highly helps us to know what are those two compounds in the thin layer chromatography. Now, because here the stationary phase retards the motion of compounds by adsorption, generally the speed with which A and B will depends upon the adsorption strength towards this stationary phase, right? So here from this solvent level or this spotting, here I put that spot here, right? So from here you need to mark it down this distance as D2 and this distance as D3, and from here to this solvent front is D1. So RF value of A, how can I found RF value of A is equal to distance moved by the compound, that is D3, by distance moved by the solvent front, that is what, D1. RF of compound B, distance moved by the compound B, that is D2, by distance moved by the solvent front, that is D1. Just like as surface tension, density, viscosity, those are what which are physical constants for each and every compound, and and those are constant values. Suppose if I did the experiment and some other did that experiment at some other country, both of them should get the same result. Surface tension of water is same, right? So similarly, RF values are also physical property of the compounds. So already we have the RF values of different compounds. Let us suppose take the same example in column chromatography. Suppose I am separating orthonitroaniline and paranitroaniline by using this TLC. Orthonitroaniline have some RF value, that is fixed value. This paranitroaniline also have the RF fixed value. So now what I got from this experiment, this RF values are compared with that nitroaniline RF values, for which it is correlating. By using that table, we are going to tell that yes, this is orthonitroaniline and this is paranitroaniline. And always this RF values depends upon the mobile phase what we are selecting and the nature of adsorbent, that is whether we are using silica gel or alumina G, okay, and also thickness of the adsorbent coating. Some students may pour silica gel G evenly and somebody pour with a thickness may increases for some of them. So that's why depending upon the thickness of this slurry as well as the silica gel or alumina what we are using for preparing the slurry and the solvent phase what we are using, depending upon these conditions this RF values will be changed. So finally using TLC is most widely used technique because we need very less amounts of solute and very less amounts of mobile phase, and moreover very time is very important for everyone, right? In a very less period of time we will get highly accurate values by using this TLC. So there are 4 steps. One is stationary phase, that is preparation of TLC plates, and application of sample, that we are calling it as spotting, and development of TLC plates. In the TLC chamber we are placing that plate and we are seeing the level, how the level is raising, and detection of the compounds. If those are colorless compounds, we are placing that chamber in iodine for some time so that the colors will appear. By using that we are telling this is more polar compound and this is less polar compound. And how can I say yes this is B and this is A? By using their retardation factor values. So that's why this TLC is very important, and even for your exams also TLC is the most important. And this is one more diagram how this solvent slurry is poured onto the TLC plate. Everything I showed in the online classes, and this is the TLC chamber. In that, there we are placing the slide like this. Okay. After some time, visualization will takes place. In the next class, I am going to discuss about paper chromatography.